Alright, welcome back to your favorite technical mathematics class. We're going to take a look at logarithms today. So we're going to convert between exponential. We talked about exponential last time, and logarithms, which are the inverses of exponentials. And then we'll evaluate those using a calculator and do some basic graphs as well. So last time we talked about exponentials, which like a basic exponential. Here's the basic exponential 2 to the x, okay? And a logarithm is just its inverse, okay? So it's flipped around the line y equals x. This, for example, is log base 2 of x. It's the inverse of 2 to the x, okay? So logarithms can be written in two forms, okay? If b to the x equals n, this would be the exponential form. Let me write it here. So this is the exponential form of logarithm, and this is the logarithmic form over here. Log base b of n equals x, okay? So for example, 10 to the third is 1,000. 10 to the third equals 1,000. That right now is in exponential form, okay? We can put that in logarithmic form. And here's how I like to remember it. So I put the log here, equals here, and I go 10 to the third is 1,000. So in other words, log base 10 of 1,000 equals 3. Log base 10 of 1,000 equals 3. Because again, b to the x equals n. The logarithmic form is b to the x equals n. In other words, log base b of n equals x. Okay, so let's do some more. 10 to the 0.6667 equals 4.6419. Let's do the logarithmic form. I'm going to write the log here. The equals over here. And I'm going to go 10 to the 0.6667, 4.6419. So log base 10 of 4.6419 equals 0.6667. That's the logarithmic form. 5 to the negative 4 is 1 over 625. Let's do the log form over here. 5, negative 4, 1 over 625. So log base 5 of 1 over 625 equals negative 4. Last one. 3 to the 4th equals 81. 3, 4 is 81. So log base 3 of 81 equals 4. And that's the logarithmic form of each of those numbers. Now let's do it the other way. So now we have the logarithmic form over here on the left. Log base 5, 125 equals 3. Now what would that be in exponential form? So I look at the log form here and I go 5 to the third equals the 125. Let's do the next one. Log base 3 of 1 over 243 equals negative 5. So it'd be 3 to the negative 5 equals 1 over 243. This one's log of 100 equals 2. Now notice right now on this one, there's no base. If there's no base, that's called the common logarithm, and they expect you to know that it's a 10. So I would go ahead and write the 10 in there. So that's a base 10. This one's also a base 10 below it. So base 10, if they don't write the base in, it's a base 10, common log, okay? And so this one would be 10 to the 2, 10 squared, equals the 100. Now let's do that last one. Log of 0.0001 equals -4. Again, they didn't write the base in, so it's base 10. So it would be 10 to the -4 equals 0.0001. And so this is very helpful to be able to go back and forth with logarithmic and exponential form. It's very helpful to find the value of a logarithm without using a calculator. So for this first one, we have log base 2 of 16. And so what you do is you say, well, I'm trying to find the value of this, so let me set it equal to x. I'm trying to find what x is. And so what I do is I say 2, I put it in exponential form. So I go 2 to the x equals the 16. And then I answer that question. What would x have to be? Well, if x was 1, it's not 2 to the 1. 2 to the 1 is not 16. Let's see, is x 2? 2 squared would be 4. That's not 16. 2 to the third is 8. How about 2 to the fourth? That's what it is. 2 to the fourth is 16. So x has got to be 4. X has got to be 4. So we just found x. Log base 2 of 16 must be 4. That's what x was, right? So log base 2 of 16 equals 4. Let's do some more. A little room here. Let's do that second one. Log of 1,000. So first thing is we say, well, I'm trying to figure out what this is, so let me set it equal to x. What's the base if it's not shown again? The base is what? Good. That's very nice. And now let's put it in exponential form. So it would be 10 to the x equals 1,000. And then what is x? What would x have to be, you guys? 10 to the what is 1,000? We know 10 to the 1 is 10. 10 squared is 100. But 10 to the third, that's what we want. 10 to the third is 1,000. So, as mentioned, x must be 3. Therefore, now we know what x is. So log base 10 of 1,000 is 3. That's what it is. Because 10 to the third is 1,000, right? Next one here, log base 4 of 64. So we'll set equal to x. And then we'll put it in exponential form. 4 to the x equals 64. Well, 4 to the 1 is 4. 4 squared is 16. 4 to the third, that's what it is. So 4 to the third is 64. So again, x must be 3. So log base 4 of 64 must be 3. And let's do this last one here. Set equal x. Notice they don't give us a base, so it's got to be base 10. Put in exponential form. 10 to the x equals 0.00001. And let me write that a different way. That is 10th, 100,000, 10,000s, 100,000s. So that is 1/100,000ths. That's 0.0001. So 10 to what is 100,000? Well, I know like 10 to the -1, that's not it because that's 1 over 10. Right? So it's not 10 to the -1. 10 to the -2. I'm getting closer. That's 1 over 10 squared. Or 1 over 100. Right? That's not it. I'm trying to get 1 over 100,000. 10 to the -3. That's 1 over 1,000. 10 to the negative 4. It's 1 over 10,000. This is what I want. 10 to the negative 5. That's 1 over 10 to the 5th, which is 1 over 100,000. So x has got to be negative 5. X has got to be negative 5. Hence, log of 0.00001 is negative 5. So the answer there is negative 5. Okay. Now these next ones, we're going to use a calculator. A basic scientific calculator can only find a common logarithm. It can only do base 10, a basic scientific calculator. So let's punch in log 0.0327. So again, it can only do base 10. That's the log key on a basic scientific calculator. So let's go ahead and pull up Desmos, desmos.com. Let's go to the scientific calculator. And let's punch in log. So I go to my functions right here. Click on the functions. And you see the log right there. Again, that log is base 10. So I punch in 0.0327. Parentheses. So you get negative 1.48545247. Let's go ahead and punch that in. Round to 4 decimal places. And so right here, so I look to the right of the 4 and it looks like it's a 5, so that'll bump it up 1.4845. Okay, let's do a log of 120 as well. Punch in log of 120 now. Looks like we get 2.079181246. Punch that in. Round that to the nearest to 4 decimal places, so right there where the 1 is. So the 1 to the right is an 8, so it'll bump it up 2.0792 approximately, right? 2.0792. Just FYI, you guys, if you go to the graphing calculator in Desmos, you pull up the keyboard, click on functions there, go down. It'll actually do a different base for you. So if you find, log, where is it? Log base A right there. Click on that. So you can do like log base 2 of 16. Log base 2 of 16. And notice it gives you the 4. All right, so you can check yourself on those other ones. All right, let's keep going. That's how you do a different base with the graphing calculator. Let's go ahead and find the value of the variable here. It's given in logarithmic form. And so we'll go ahead and put it in exponential form. So here's logarithmic form, log base 4 of 16 equals x. Find the value of the variable. Well, put it in exponential form. So 4 to the x equals 16. Well, what's x got to be? We know 4 squared is 16, so x has got to be 2. So log base 4 of 16 has got to be 2. Right, and you can check it again with that graphing calculator. Let's do the next one there. Log base 5 of 125 equals x. So we know 5 to the x equals 125. Well, 5 squared is 25. That's not it. 5 to the third, though. 5 times 5 times 5 is 125. So x has got to be 3. So we know log base 125 equals 3. That's the x value on that one. Okay, let me erase this, give myself a little room here. do this third one. Third one is log base 7 of x equals 3. So I'm going to go 7 to the third equals x. All right, I'm going to go 7 to the third equals x. Well, this time notice that the x is just on the right-hand side. So I just got to find what 7 to the third is. So 7 times 7 times 7 is 343 is what x is. And I'm all done. I found the value of the variable there. Let's look at the fourth one there. Log base 16 of a fourth equals x. So I'm going to go 16 to the x equals a fourth. So if you think about this, I don't want to go 16 to the 1. That's 16. Or 16 squared, that's like 256. It's too big, right? So what about 16 to the negative 1? Well, that's 1 over 16. That's not it. 16 and negative 2, that's 1 over 16 squared. That's 1 over 256. That's not it. So I got to be a little more creative on this one. Think square root. 16 to the negative a half. That's 1 over 16 to the 1/2. In other words, 1 over the square root of 16, which is 1/4. So x is actually negative a half. That's kind of a tricky one. That's what your x is here, negative a half. Okay. Let's do that fifth one there. Log base b of 81 equals 2. So I'm going to go b squared equals 81. So what squared is 81? Well, 2 squared, it's not 2 squared. 3 squared is 9. 4 squared. So I'm like, oh, it's got to be 9 squared is 81. So b is 9. B is 9. And finally, that last one there. Log base b of 5 is a half. So b to the 1/2 equals 5. Well, anything to a 1/2 power, that's the square root of b. So the square root of what is 25? Well, we know the square root of 25 is 5. So b's got to be 25. On that, okay? Let's take a look at this one now. Use a graphing utility to graph the following. Y equals 3 log base 10. That's log base 10, right? It doesn't show it. 3 log of x. So I'm going to go ahead and clear this out. Y equals 3 log of x. And there's your graph. And notice there's gives you that point right there, 1, 0. If you want some other points on here, you can go ahead and click the edit list. Click on the table. And so like they had 1, 0. You know, if you threw in like 2, let's see, it gives you 3, 4, 5, 6, 7, 8, 9, whoops, 9, and so on. All right. You get a few points there. You could even go with -1, not defined. Oops, I meant 1/3 or 1/9. Anyways, there's some other points there down below. Negative y values. Let's go ahead and do the next one there. Negative log of 2x. Let's graph negative log of 2x. Y equals negative log of 2x. Parenthesis. You can see there's that point, 1/2, 0, and you can get some other points on there as well. 1/2, 0, plug in 1, 2, 3, 4, anyways, 5, whatever you want to plug in there. Okay. All right, let's do an application here. So Richter scale uses a logarithm. Use the Richter scale to measure the magnitude or strength, right, of an earthquake of intensity I with this formula where I sub 0 is the minimum base level. Find the Richter scale reading of the 1906 San Francisco earthquake where I is 2.5. So find the Richter scale. Let's write this down. So this is log base 10 of I over I sub 0. And the intensity I of the San Francisco earthquake, so I'm going to replace I with that 2.5 times 10 to the 8 I sub 0. And we have an I sub 0 on the bottom, which is the minimum base level. So notice the minimum base level cancels out on this. And so all we're left with is log of 2.5 times 10 to the 8. So I just got to punch that into my scientific calculator. Log of 2.5 times 10 to the 8. Let's see what that gives us. It looks like we get 8.397940009. Let's round this to the nearest. Let me write that down here. Let's go to the nearest tenth, so 8.4 is the Richter scale reading of the 1906 San Francisco earthquake. Well, thanks for taking notes. See you guys next time.